Imagine minuscule robots, no bigger than a grain of rice, that could carry out complex bodily functions without causing any damage. Energy storage and nanotechnology developments are making this future idea a reality very quickly. Researchers are creating tiny robots that run on invisible batteries, creating new opportunities in engineering, environmental monitoring, and medicine. Let's explore the innovative science underlying these tiny devices. Brand new little robots. A revolutionary new tiny battery created by MIT engineers has the potential to revolutionize the use of autonomous robots the size of cells for drug delivery within the human body. This battery is one of the tiniest ever created, and because of its size and capabilities, it has the potential to enable technical feats that were previously unthinkable. With dimensions of only 0.1 mm in length and 0.002 mm in thickness, roughly the width of a human hair, the new battery is remarkably small. It is designed to provide remarkable performance despite its tiny size. In order to oxidize zinc and produce electrical current, the battery utilizes oxygen from the surrounding air. Given its small size, this method enables the battery to reach a potential of up to 1 volt, which is a noteworthy accomplishment. The power output is adequate to power small circuits, sensors, or actuators, making it a practical energy source for microrobots and other like devices. Numerous important funding sources provided support for this groundbreaking study. The study received funding from the National Science Foundation, the U.S. Army Research Office, and the U.S. Department of Energy, underscoring its potential significance in a number of domains, including technology, energy, and defense. The project was further advanced by a MathWorks Engineering Fellowship as well. These institutions' participation demonstrates the need of creating such cutting-edge technology, particularly those with a broad range of uses like self-governing microrobots. This battery has uses in many different industries, most notably in industry and medicine. The battery's small size and ability to power tiny robots could transform precision medicine in the medical field. Cell-sized autonomous robots, powered by this battery, could be used to navigate through the human body and deliver drugs to specific locations, enabling highly targeted treatment with minimal side effects. For conditions like cancer, where localized treatment is critical, this technology could greatly enhance the effectiveness of therapies. Beyond medicine, the battery could play a pivotal role in industrial maintenance, particularly in monitoring infrastructure. For instance, microrobots equipped with this power source could be deployed within gas pipelines to detect and pinpoint leaks in real time, offering a more efficient and cost-effective solution than traditional inspection methods. The robot development challenges. Developing a small but powerful energy source for tiny robots is a tough engineering challenge. For years, Michael Strano, a professor of chemical engineering at MIT, and his team have been working on creating tiny robots that can detect and react to changes in their surroundings. Of the biggest challenges they've faced is finding a way to give these robots a steady and compact power source. Without this, these tiny robots can't reach their full potential, especially when they need to work in tight or hard-to-reach places. Some researchers have tried using solar power to run tiny devices. While this idea is creative, it has some big downsides. Solar-powered micro-robots need a light source, usually a laser, to shine on them constantly so they can work. Because they rely on this light, they are like puppets controlled by an outside force, which limits how independently they can operate. If the light is blocked or turned off, the robot stops working, making it less useful and unable to move freely. For these tiny robots to truly work on their own, especially in dark or hard-to-reach places, they need a built-in power source that doesn't rely on external light. The need for these tiny robots to work without being connected to an external power source is what motivated Strano to create a zinc-air battery designed just for micro-robots. Unlike systems that rely on solar power, a battery lets these small devices operate on their own without needing any external connection. This makes it possible for the robots to explore places where outside control isn't practical or where light isn't always available, like deep inside the human body, in underground pipelines, or in other closed-off areas. By creating a zinc-air battery that is both compact enough to fit inside these miniature robots and sufficient to provide the power required for prolonged operation, Strano's team achieved a significant achievement. They decided on a zinc-air battery since it generates power by reacting with zinc and oxygen from the surroundings. Because there is no need to store oxygen inside the battery, this design is incredibly effective and small. By pulling oxygen from the air, the battery stays small and lightweight while still giving enough energy for the robots to work properly. The battery created by Strano's lab is a major step forward in microrobotics. By placing a power source directly inside the robots, his team has made devices that can operate on their own in ways that weren't possible before. This increase in independence is important for tasks where constantly controlling the robots or needing human help isn't practical. For example, in medical treatments, these tiny robots could be sent into the body to reach specific cells or tissues, moving on their own without needing an external power source. In industrial areas such as gas pipelines, these battery-powered robots could be used to inspect tight spaces and find problems that larger devices or traditional methods might overlook. The zinc-air battery creates new opportunities for microrobotics, allowing these tiny devices to work in conditions where they would have been useless without an external power source. Breakthrough moves Strano's idea of fully autonomous microrobots capable of responding to their environment closer to becoming a reality. It also paves the way for future developments in small autonomous systems that could be used in a variety of fields. The study demonstration. In the study, MIT researchers demonstrated that their tiny battery could generate enough energy to power various components and devices. For example, they used the battery to run an actuator, a type of mechanical part that moves something. In this case, it was a small robotic arm that could be lifted up and down. The fact that such a small battery can control even a basic robotic function like this is a significant achievement, showing that it has practical applications in robotics. The researchers also powered a device called a memristor with this battery. A memristor is an electrical component that can remember previous events by changing its electrical resistance based on what it has experienced. In simpler terms, it can store a kind of memory. For example, if the memristor is exposed to a certain stimulus, like an electrical charge, it will remember that by adjusting its resistance. For small robots that must adjust to their environment or recall particular circumstances they have experienced, this capacity to store information is crucial.